So hold on. Are you recording?
Yeah.
Okay. This is video number 3, auto navigation simulation. Actually, auto navigation demonstration. The robot will travel to 3 different waypoints. One in the first room. The second, it will then change rooms, go to the other room that is over there. Go to another waypoint there, and then go back to the first room through this little doorway here. Roughly in the area of where home is, while clearing obstacles. At your convenience. Making the robot realize that these are 2 different rooms is not trivial, because it requires the robot to have a model of the one room as well as a model of a second room, and then in addition to that it needs to have a model of the intersection between rooms, which is why we have those little beacons there, those black things, sitting on the edge of the cardboard boxes. Found the obstacles relatively okay. Oh, and now it's trying to go home. It realizes that there is a wall and goes, oh snap.
Next room.
Yep, it will move to the next room eventually. Come on, little buddy. You'll clear it. You'll be okay. You'll impact it. I know. That is an artifact, as I mentioned in the other video. The robot does not have a model of how large it is. Therefore, we included in a separation area between the obstacle, which is marked as black on the map, and the gray area in the map that, the gray area in the map, which is an area the robot is not allowed to go in order to avoid the obstacle. So it happens occasionally that the robot impacts with those small white boxes and the walls, but that's not a big deal. With some more time we could fix that. Yeah, with a second lateral distance sensor, right? Or just tell the robot you're this wide. You're this wide. Have to rework the map a little bit. You know what happens.
Well, if it knows the obstacle's there, period, it's very unlikely it's going to come into contact with it.
That's right.
Home now,
So the robot found its second destination and will now find a more or less optimal route to go back home. The pathfinding algorithm is an implementation of a Dijkstra's algorithm, specifically the A-star optimization. Which is an algorithm has been around for like decades, and it's basically the golden standard for how to, it's dancing around a little bit. Gold standard for path optimization.
Yeah, the MarvelMind over here is having some issues.
Yeah, it occasionally happens that the robot
It's touching the wall, so
needs
it needs
to
move to complete the turn.
There you go. Occasionally, the wall clearance isn't quite perfect. So occasionally, when the robot impacts the wall, the clearance with those little acoustic beacons, the black units I just spoke about, it gets too little, in which case the robot needs to be gently nudged.
Fortunately, in more actual examples, not so much an issue because those door frames are narrower than the boxes we have.
Yeah. That is true. So the reason why the robot backtracks a lot is because it's finding obstacles and then it's trying to find an optimized route, and then usually backtracks a little bit in order to see if from that position he has a better chance of getting an optimal route to home. And it looks like he found one, and he's going. And he's home.